I guess we'll start our talk now. Thank you to you all for coming to our talk. And then I kind of gathered you must be all like interested in Pulsar and then also Spring developers. So thank you very much, because right now it's actually tough too when Josh Long is also talking. We kind of knew, it's going to be like this, but that's okay. Josh is our good friend too. So yes. So thank you. So we're going to talk about Spring for Apache Pulsar. How many of you, let me ask, are already maybe working with Pulsar by any chance? No? Or you have heard of Pulsar? Yeah, most of you. And how about working with Kafka? Probably most of you. Okay, great. So now we're going to introduce you to Spring for Apache Pulsar. Let me start. And before we start, too, if you are interested in this slide deck, this is the link and also the QR code. But no worries, too, if you miss it, we're going to be sharing the slides, too, with the organizers. So just want to make sure folks are still taking picture. Yep. Okay. Okay, cool. Okay, so just a really quick intro, as we started a bit late with all the equipment. So we have Christophe from France, and then we are colleagues at DataStax. And Christophe, I'll let you introduce yourself more.
Yeah. So I'm a software engineer at DataStax, and I'm working on the Pulsar team. So my work is basically to make the ecosystem of Pulsar and to improve Pulsar to make it the best streaming solution on the market. I love open source, and I'm a committer, of course, of Apache Pulsar, but other open source projects such as JHipster or Open API Generator.
Yeah, that's right. Yeah, thank you. And my name is Mary Grygleski. I'm a developer advocate at DataStax. So as such, I do travel around. I do more of the outreach type of work. But before this, I was a developer advocate at IBM, just FYI. And let's see, what other things? I'm also Java champion, as well as president of the Chicago Java Users Group. And just to give you a quick kind of thing intro too, is that Christophe and I work at DataStax, and then I met him finally in person.
Yeah.
A month ago in Atlanta, Georgia, when he came to the US and spoke at DevNexus. And so I thought, well, this is great. And now with Spring I.O., I'm just so happy Christophe can come too and we can present this. And
I am too.
Kind of, yeah, so again, Christophe works very much, hands-on into the nitty-gritty, so he will be able to answer all your questions. So yeah, thank you. All right, so that's that. And this is a quick, right, just give you an idea, today's agenda. We'll be introducing to Spring and Pulsar, giving you also a high-level overview of Pulsar, then also do a live demo. We'll spend more time on that than talking, and then also give you an idea of the feature roadmap we have, and then we'll take any questions and try to answer all of your questions too. So that's that. Okay, so introduction. Okay, that's my. Right. Yeah. Okay. So what is Apache Pulsar? So very quickly, high level, right? It's an open source project that was started by Yahoo back in 2013, something around then. And it was because they were working with Kafka, then they realized there's shortcomings in Kafka. As we know, Kafka is powerful as a distributed messaging platform, but it wasn't. It was designed before then, right, at LinkedIn, and then it wasn't taking into account, it needs to operate in the cloud. So that's why Pulsar came along, and it's really with the, the knowledge or the awareness we need to serve, do event streaming, messaging in the cloud, very cloud native. So it by itself, Apache Pulsar is just built with that in mind. So very cloud native is a distributed messaging and streaming platform. And also, being cloud native, it's actually also has a feature called multi-tenancy. So that's already natively built into it and makes it very nice, because otherwise then you'll have to organize your messages accordingly, according to your applications, for example. But then with Pulsar, it's kind of by nature, it already has this multi-tenancy supported, and you can leverage on that and basically use it, right? For example, if you're a data center company and you have different, you're running a cluster, you're servicing multiple clients, and all of these messages needs to be organized accordingly, then you can leverage on this multi-tenancy feature is already built in. Just group them by different tenants, right, to kind of manage all of your messages. So that's an example, and very high performance of these. Okay, and now then, okay, so Spring being like the most popular development framework runtime in the Java land, right? And so, Spring 2 is now also starting to support Apache Pulsar. So now that's what we're going to talk about, the Pulsar client for Spring. And essentially, too, we are bringing Pulsar into this Spring ecosystem. And also, too, okay, so essentially, too, it is a library, right? Just that helps you. This Spring Pulsar client library helps you to create standalone production-grade system to using, kind of easy Spring-based applications. You can build it easily, and that's what we're going to be demonstrating shortly. So, okay, and some backstory, and we can have Christophe.
So, explaining how I worked with on the Spring Pulsar and why I can talk to you about it today. So Spring Pulsar is a project which was bootstrapped by Sobi Chaco and Chris Bono from the Spring team. They started by doing the imperative side of Spring Pulsar. And as soon as they delivered their first version, maybe 5 minutes later, someone arrived and says, can we have the reactive API? And so they said, well, we will support this later. And then 5 minutes later, another person arrives and says, is there a possibility to do reactive? So everyone wants to have reactive. And it makes sense when you're doing streaming applications to have reactive support. The good thing was that at the same moment, I was working with my colleague Larry Hotari at DataStax on supporting a reactive client for Apache Pulsar. And Larry and Sobi, they met at the Pulsar Summit in the US, and they talked together, and so they said that we have the reactive client which is arriving, so we could do the reactive support immediately for Spring Pulsar, and that's how I started to develop the reactive support for Spring Pulsar. So we are going to present to you the high-level overview of Pulsar, all the concepts. If you're familiar with Kafka, it's very similar.
That's right, yeah. Okay, yeah, I'll start first and then, okay. So just very quick intro, right? It's basically Pulsar is built on the pub/sub pattern, just like Kafka. So if you're working with Kafka already, you can use it right away, just like that. And basically, right, we know messages are the ones that move, data, through the services, and it relies on you, identifying a topic. So then, producer can produce the messages to the topic, and then interested subscribers will have to subscribe to the messages in order to receive the messages. So very much too is a subscription-based type of model that we have in here too for Pulsar. And as we can see a little further, is that Pulsar has our own way of organizing the subscription, and because of that, it's actually how it organizes is basically takes away some of the limitations, I'd say, right, on Kafka and also RabbitMQ, which we'll show you quickly too in here. So as such, right, there are like 3 primary subscription models in Pulsar. As such, the very top one is exclusive. Exclusive, it's basically only one consumer for that subscription. And so in this case, you are kind of able to turn Pulsar into like a queuing type of thing, right? So it becomes one-to-one in this case. And then there's also a mode is called shared mode. So shared mode is essentially, if you want scalability, you can add more than just one consumers to your subscription. And in this case too, yeah, it also kind of helps with, again, if you need more consumers, it's kind of, you can use this mode. But one thing to kind of note is that then this shared mode doesn't guarantee your message ordering. So I think there's also a key share mode that's quite new too in here that will actually allows you to have messages being ordered in the way that it's supposed to be. And okay, and then there's also one more mode is called failover mode. And so as such too is basically it allows for multiple consumers, but only one is the primary active one. So if for some reason, if that consumer goes away and something happens and then it's not there, then the rest of them, one of them from the rest in the group will take over as the primary. So that's failover. So essentially, yeah, these are like the 3 primary subscriptions. And we talk a bit about too, there's some, for example, like shared subscription is essentially it kind of works like RabbitMQ type of, way of
Shared subscription is what you have in RabbitMQ, typically, competing consumers. And failover is what you typically have in a consumer group in Kafka. And Pulsar can support both at the same time.
That's right. So that's kind of very special with Pulsar too. Yep.
Okay, so now let's talk about the architecture of Spring Pulsar. So we saw that we have topics in Pulsar that are managed by broker. The broker will communicate with producers and consumers, and to build these producers and consumers, there are a number of client APIs for a variety of languages. Of course, the ones that will interest us today are the Java ones. There are 2 kind of drivers. The first one is the historical one, it's the imperative client, and the new one that we just released is the reactive client. Spring Pulsar uses these clients and adds some interesting features on top of it. So even if you just put Spring Pulsar and you want to stay low level, not use the Spring primitives, you already have some nice things that will be auto-configured for you. For instance, you have type-safe configuration. It will configure, it will auto-generate a client. You have factories to easily create producers and consumers. So that's the first level of nice things that Spring Boot gives on top of the Java driver. Then if you want to start to use more abstractions from the Spring framework, then we add the Pulsar template and the Pulsar listener. If you're familiar with the Spring ecosystem, Spring Data has a JDBC template, Cassandra template, Mongo template, you have Kafka template. Okay, so now we have the same kind of primitive, which is the Pulsar template, and the Pulsar template enables you to produce messages to Pulsar. And the Pulsar listener, it's a bit, it's an annotation that automatically creates a consumer in your application, and so Spring Boot discovers a Pulsar listener and creates a consumer, and then you only have to create the logic to process the messages. You don't have to handle the life cycle of the consumer. We have the imperative Pulsar template and Pulsar listener, and we also developed the reactive Pulsar listener and the reactive Pulsar template. So if you want to have reactive APIs. So this is a very simple hello world to show that with minimal code you can start with using Spring Pulsar. This is working code, so really basic. I don't spend too much time on this because we will do the demo afterwards. So this is reactive counterparts, quite similar. We see that the void became a mono void. That's one of the differences.
Okay, just some additional noteworthy features if you're seriously wanting to start considering Pulsar, right? So Pulsar also has this feature called Pulsar I/O. So as you know, most of the time if you're working with streaming system like this, distributed messaging, you're building data pipelines. So there are source and sync connectors. So with Pulsar I/O, they're already pre-configured, over 80, I think the pre-configured connections, right? You can have source or syncs, for example, like Kafka. We support that, as we have connectors with that, and other databases like Cassandra at our company too, and all kinds, right? Oracle database, whatever, Postgres, and so all of these Pulsar I/O. So these are pre-configured ones. But if let's say you want to connect to something that isn't already there, you can also use the Pulsar I/O to develop and customize your own connectors too. So that's something very flexible about it. And then also, there's a feature called Pulsar functions. So these are like bite-sized type of, kind of functionality, much like AWS Lambdas or Azure functions, Google functions like those that allows you to write small pieces of code and you can quickly deploy and then basically let the infrastructure, Pulsar infrastructure supports it and to operate in the cloud native environment. Okay, and then also other features like, for example, is guarantee messaging, all these error handling to Pulsar will take care of, right? Dead letter topics, retries, message deduplication is all there as well. And also, just also note is that it separates out too. So it doesn't manage all of the log messages. The distributed persistent message store is actually handled by Apache Bookkeeper too. So, and Bookkeeper is very efficiently managing all of the log messages. So that's something also in there. And then also there's a Pulsar Reader API support too, in which you can use it to navigate through your log messages and search for messages to kind of like say message playback and replay those things too. Okay, and one more thing is basically also automatic, like schema topic, there are automatic detection and resolution as well. So in other words, Pulsar is already like a very kind of self-aware type of, cloud native ready kind of event streaming distributed messaging platform for the modern age, so. Okay, and here too, just to kind of quickly show you, is basically these are the number of, many databases, connector, messaging, streaming. You see Kafka is in there. These are language client, there are different bindings for it, and so monitoring, observability. So you can see there, this is like the huge list of supported, kind of essentially sync and source connectors that Pulsar supports. So, okay. And some more noteworthy features are the Spring Cloud Stream, we are going to have Pulsar Binder, that is in there. And then also GraalVM, we have native image support as well. And then also one more thing is basically some built-in some observability too, but that's more on the imperative side as a starter. So. Okay, so overall, just want to summarize the benefits of using Pulsar is basically increase your productivity, right? Your developer velocity, as well as like increase your experience, overall experience too. Okay, so now we get to the live demo.
Time for
yeah, thanks for your patience.
Live demo.
Yeah, okay, just want to make sure. Okay, we have time. And we also have stickers too, so don't forget.
Okay.
Okay.
So yeah, it's big enough. We will do a quick live demo. The idea is to have a basic application, a little more than a hello world, but something that we can demonstrate quickly in this presentation. So I'll first start with a little joke I had this morning. So you've heard that they released Spring Boot 3.1 yesterday, and so they updated start.spring.io, and of course my demo, I don't even know if it works with this version, so I had the surprise this morning. They also updated this one, so I had to download all the dependencies. So this is the kind of surprise you get. Okay, so I'll add OpenFeign, so to have a REST client, and I'll have I'll add so the Pulsar Spring for Apache Pulsar. This is for imperative. There's also reactive. We'll see that later. Yeah, and generate my project. Oh no, I will change a few things. Call Acme artifact Pulsar. And generate. Okay, so before we start, so undipping, okay, we will use an external service to get data. For this, I will use randomdataAPI.com. It's a nice service. It generates for you random data, so we can do it for users. Then we have, each time we call the service, we get a different user. So brain.jazz, Tori Winchester, Cassie Ince, etc. Okay? So let's go to our newly generated application. So in the build.gradle, we see that the Spring Pulsar starter was added. Is it big enough?
Yeah,
okay. And we'll start with an application. So first thing, maybe you want to talk about
Oh, okay, sure. Okay, yeah. Sure. So now, yes, yeah. So this is your, the user. That one will hold the user that will be generated. This is the one, yeah.
Yeah, so we have the fields that corresponds to what we saw in the web service.
That's right.
Okay. Okay. So I create a client. So it will be a Fein client.
That's right. Yeah, and this Fein client, something I learned from Christophe, is so good, right? For especially if you want to do testing, quick thing, generates all of these fake data that you can use for your testing. So that's
okay.
Cool.
So I put the URL. We will have a get mapping. Okay. It's on slash. It's with the S users. Okay. So this is Copilot. It's helping me a lot. Okay. I only get one user. Okay, one user, get user. Okay. Now, usually what we want to do is to create a service.
Yeah.
Okay, it's an add service.
That's right.
Okay, we inject the client.
Yep.
Okay, it's read. Oh yeah, thank you. I like this.
Yep. Okay. Yep.
Okay, it's read because I need to include enable Fein clients, so it's discovered.
Yep.
Okay, so we have our service equals the client. Now we can create the service. We can inject the service into our Pulsar application.
Yep.
I will do something that don't yell at me. It's just for demo. I use field injection and not constructor injection. Don't do this at home.
Yep. That's
okay, so this is where I use the Pulsar template, which is automatically created because I have the Spring Boot starter for Apache Pulsar. Okay, and so now we will try to source some users into our application. So we use a Pulsar template called the same method. So we see that we do topic, message, schema. So let's go. Topic will be user topic. This is okay. Okay, and schema is I choose JSON for my schema.
class.
Okay. I get the result is a message ID.
That's right.
And we will just print the return result message ID. Okay. Now I'm changing a little the produce. Okay. We will schedule this. Add schedule. Enable scheduling so that it's aware of my scheduled job. Okay, here for the scheduling, we'll choose every 1 second, and we can start our application. It should work, hopefully.
Yeah.
Okay.
Yes.
So producing.
Producing.
Um,
Okay, great.
I can start a client with the Pulsar client, and we see that we produce with our application, and with this client, I see that I get my users. They have a random name each time: Eloy, Rab, Cecilia, etc.
That's it. Yeah.
Okay, nice.
Great.
So now we want to see the consuming part. Okay, thank you, Copilot. This is exactly what I want. This is awesome.
Yeah.
Okay, restarting. Oh, there's a little thing that is not good.
Oh.
I need to say which topic I want. Okay. And we saw that there's a schema type.
Oh, okay.
Okay, now we can start again. Okay, so we see produce, consume, produce, consume, produce, consume.
Yeah.
Okay, so we have our first application working. We can produce and consume. It was really quick to do. There are some defaults in Spring. So when it sees a class or a record, the default is already schema.json. So Spring detects that and it makes it the default. So I can just remove them. So this is the nice thing about Spring. It's opinionated, and most of the time it takes the good decision. So relaunch. Okay, so it still works. Another thing we can do, so I will rename this to YAML. Okay. Just some snippet to minimize the logs, and another snippet. So in your application.yaml, you can configure some things. For instance, here I'm configuring a mapping between the user object and the user topic. So it means that everything that concerns the user, if you produce or consume, it will go to user topic. So this is nice because now it's driven by configuration. I can modify it externally, and also I don't need to provide it into my application, so it becomes even simpler. Okay, we can check, restart. Okay, still producing, consuming, it works. On my client, I still get on the user topic the messages. Okay. So this is good. We have done imperative, but we all know that reactive is really cool. So we want to do the same thing now with reactive. So we have we will add the reactive starter. Okay. This will add the reactive starter in my build.gradle. I'll copy that, copy paste, because I don't want to type everything again. Okay. Pop Gradle. Okay. So now in our user service, what we want to have, we want to work with a flux of user. So the primitive, reactive primitive for a stream, we'll call that multiple users. Okay, this is not what I want to do. I want to mono from supplier. Okay, repeat indefinitely. And we'll delay every second. Okay, nice. Now here, let's start fresh. We remove our producer and consumer. We'll use reactive Pulsar template instead of the imperative one. And we go again. create a source users method. Okay. This time, when you go reactive, often you start from the data. User service, multiple user. Okay. We will map this to message spec off. So this is wrapping my value into a message spec. Message spec is a little more than just a value. You can configure metadata and key, etc. And the reactive Pulsar template can take a message spec a flux of message spec directly to send to Pulsar. And I subscribe. Okay. So now I need to start this at the beginning of my application. I'll do an application runner. Okay, and this works by returning a function that takes args and returns my code. Okay. So restarting, this time it will be done reactively. I should produce to my, you don't see anything because I didn't say that I want to print anything. So do on next, message ID. Okay, it's not a message ID, it's a result. We will, it was produce. Okay. Message ID. Okay. So this time we should see something. Okay, we are producing.
Good.
And here we are still consuming. Okay, now we want to do the reactive Pulsar listener. As we saw, now it's not a void, it needs to return a mono void. So we consume user. Okay. So I'm using the primitive that gets the messages one by one. It's still in the reactive pipeline, but I get the messages one by one, and I can just write the code for my handling function. So I just do consume, return mono empty. So this will print what I have here. And since I return mono empty, there's no error. The framework will automatically acknowledge the message. If I had written, for instance, mono error, then the framework would negatively acknowledge the message. Okay, so let's do it with, I'm rerunning. Okay, produce, consume, still okay. Another way to do it, if you really want to have the full message flux, it's also possible. So this is what I show now. So this would give you more control on the reactive messages between them because you have the full flux at your disposition. In that case, I will take the users, do a next, nice, almost that. It's not then that I want to do. I will map to, so since it's a flux, I need to explicitly acknowledge or negatively acknowledge for each message what I want to do. So here I just say, I acknowledge, okay, and I return this, changing the signature, so the signature is now a flux message result void. Okay, so this is the same as what I had done before with the mono, except that now I work on the full flux. Oh, and it's not working. Why is it not working? Right. I know. I always forgot, yes. Since we need to say that we are working on the stream for the framework to detect the handler. So starting again. Okay. consume, produce, consume, produce, consume, it's working. Cool, so now we have a system we can produce, consume. We said that we can also transform the data. So what I would like to do, I have users that come from an external service, and I want to register them. Okay, so I will create a registered user. Okay, yeah, I'm using records. If you have the possibility, use them. They are awesome. No need for Lombok anymore. No need for a lot of code, boilerplate code. So a registered user, it's a user and it has a tier. Okay, and a tier. Yeah, awesome. I just say enum and it knows that I want a tier with a basic and premium. Cool. This is awesome. I will just add enterprise. Okay. And so what I want to do is I want to transform my users, okay, to registered user. Okay. So I can do it with using a regular Java function. Let's call it register user. Okay, okay, almost. My function is a user. It returns a registered user. Here it is tier.basic. We will do something a little better. Okay, this is not secure random, so maybe you don't want to do that, but for my demo, it's far enough. Okay, values. Oh, nice. It says that I want to have randomness on the values of my tier. Awesome. So I have my function, and now I want to introduce it in my framework. So we go back to Spring starter Spring, and we will add Spring Cloud Stream. Okay. By doing that, it says that I already have the Pulsar dependency, so I have the Spring Cloud Stream binder, which is added. Okay, copy that into my build.gradle. Okay. Refresh. Okay. Now, Spring Cloud Stream works by, it knows about functions, so I just have to say that I have a bin, so now it's detected by the framework, and I can do some configuration. So I have a template for this because there's a lot of things. I need to declare which bin is a function that will be handled, so I say register user, so it's the same name that I have in my application. Okay, this will be the name of the bin. And then we configure bindings. So we say which bin, register user, is it input or output? And which parameter is it? If you have a by function, for instance, you will have in 0, in 1. Okay, I don't know if it's possible to have out 1, but anyway, it's out 0. And I say that my input comes from user topic, and my output goes to register reg user topic. Okay, and I also configure the framework to use the native decoding because Spring Cloud Stream has support for encoding decoding, but here I say no, let the driver do the encoding decoding. I also need to add this, so at the moment it's not convenient. It will probably be better and not needed anymore in later versions, but I need to say that the input is a user and the output is a registered user. Okay, so so my function is known. It will write to register reg user topic. So here instead of reading users, I will read a register user. Since I have not configured the default topic for this, I need to add it here. Okay, and we restart. Okay, so now the application is publishing to the user topic. We have a function that reads from this user topic, transforms the data, writes to the reg user topic, and another function that reads from reg user topic and prints the results. So we have the registered user with a random tier each time. Okay, so this is nice. Let's see one thing. So this is a standard error. The application took more than 2 seconds to boot. Let's see if we can do better. You've all heard, I'm sure, of GraalVM. So we'll add GraalVM. Okay, so this will add the plugin for Spring to my build.gradle. I copy this. Okay, go in my build.gradle. Okay, and what I want to do is to I'm adding some opens because it's Java 17, so we can access close the modules. Okay, so what we will now do is to compile for GraalVM. I use the GraalVM JDK, so in my case 22.3.1, and we can compile. Okay, and it's nice, but it will take some time, something like 5 minutes. Right. So cool. Meanwhile, waiting for this, let's. So if you're interested in looking at this source code, there's a link. And yeah, please. Okay. Okay,
cool. Very cool.
And we'll talk about what's next.
Yeah, what's next. So while that's compiling, it might take some time, right? So what's next? So we're going to be adding in transaction support as well as like automatic like failover support too. So that will be the next set of improvements for this.
So these are features that are supported in Pulsar already, but we need to integrate them with Spring. And you know the add transactional annotation, for instance, work to do with that.
That's right.
So the project at the moment, so this is about the project evolution. At the moment, we are not, it's usable in production, Spring Pulsar. You already have it in start.spring.io, but it's still not the 1.0 version. Why is that? It's because at the moment, everything is in the single project, and we are in the process of moving the parts to the core projects of Spring. So we will have in Spring Boot 3.2, so it's for November, I think, the auto configuration for this will go into the Spring Boot module, and the Pulsar binder will go into Spring Cloud Stream 4.1, and we will have Spring Pulsar as its own repo for the version 1.0 with only the core of Spring Pulsar. So exactly like it's for Spring Kafka today. Oh, what about GraalVM?
That's right. That's the golden question here.
Oh,
let's see.
I talked too fast. It's still compiling. So maybe while it's compiling, let's take maybe some questions.
Questions, yeah. Yes.
Yeah, microphone.
Yeah. It's not on. Still not on.
Just shout it. Okay, yeah, I can do it. We're not that many people.
Okay.
You mentioned transactional slide before. What does Pulsar in terms of the platform Pulsar support in terms of transactional writing, I guess?
Yeah. So there's transactional support in Pulsar. You can write to multiple topics, for instance, in a transaction and commit. It's real transactions. To compare it with other systems, I will not name them, but it's exactly like a transaction in a database. You have a begin, you do your operations, and then you commit the transaction.
Yeah.
And if it's not okay, it's rolled back.
That's right. Yeah. So cool. Yeah.
Okay.
Okay. Sure.
Test.
Yeah.
Okay. You talk about Pulsar and a little bit about Kafka. What would you recommend when to use Pulsar and when to use Kafka?
Of course, I will recommend to use Pulsar.
That's
Okay.
right. Yes.
You will say
But
I'm
why?
not objective. Yeah, so it has a lot of advantages. So one of the most important one is that the layer for storage is a bookkeeper, and it's decoupled from the compute, and it gives the possibility to have better scaling of the topics. For instance, in Kafka, when your topic grows, at some point you don't have storage anymore, and you need, if you add a new node, then you need to rebalance your topic to use the node. With Pulsar, you just add a new node, and there's an abstraction layer between the physical and the logical partition. So this way, when you add a new node, it's immediately available to write. I have a lot of other features that are in Pulsar. We talked about multi-tenancy. If you try to do it in Kafka, it's really hard. I know that there are even companies that are building themselves around tackling this problem with Kafka.
There's
Geo-replication is built in from day one.
Yeah.
And you can, as we showed before, you can use it both for message queue use cases and for streaming use cases. If you're trying to do message queues with Kafka, probably you're doing it wrong. You will have a lot of problems scaling your consumers, acknowledging the messages. What can I name? So many things that are better. And an important thing, if you have already a big ecosystem in Kafka, which is often the case, there's a compatibility layer between Pulsar, a native compatibility layer. It means that Pulsar can talk the Kafka protocol directly, and so there's no performance decrease, and you can use Pulsar as a drop-in replacement for Kafka.
Thank you.
I have another question. You talked about the consumers or multi-consumers for a queue or a topic where you can subscribe to. How is it managed that the consumer amount is tracking that no more consumers are listening? Because I think the consumer don't know how many other consumers are subscribed to the topic.
Right.
So how is it managed that it is not driving into endless time, keeping the message on the topic? Because if you compare it to like ActiveMQ or RabbitMQ, you send your message, it is going to be consumed, and then it's lost from ActiveMQ. Yeah. How is it managed here?
Yeah, so in the case of Pulsar, it will be the broker that will dispatch the messages and push them to the different consumers. The consumers they only say. It's like the reactive stack, they say how many messages they can accept, and then the broker will push the messages to the consumer. And then there's an acknowledgement system. So for a message to not be sent to another consumer anymore, the consumer needs to send an acknowledgement to the broker to say, yeah, okay, I have consumed this message. You can remove it from the subscription. You can configure a timeout, and if the timeout expires, the broker will consider that the message was not delivered, and it will deliver it to another consumer.
Thank you.
Yes. Your question.
So you mentioned that Pulsar supports searching for messages instead of just like doing offset-based streaming. Is it possible to build like an event store based on the Pulsar? Can you add indexes to those searches? Or are
This
you
is a-
scanning, or
this
are
is
you
a good
scanning
question.
the whole?
I'm not an expert in event store.
That's right.
From what I understand, yeah, you need more than just a message bus such as Pulsar or Kafka to do an event store. So you would need something else to index your messages.
That's right.
Oh, it's doing it again. I think we were lucky to see the full presentation because
I
now
don't know.
it doesn't seem that we can see it anymore. Okay.
That's right.
I would have wanted to show you
Yeah,
GraalVM, but believe me, it
Yeah,
works.
there we go. Yes.
Yeah, maybe showing quickly.
Oh, quickly. Yeah, yeah. Oh, here we go.
Okay, it works. And
Yeah,
see,
and
started
then-
in
Yeah.
200 milliseconds,
Yeah.
so much faster.
Much less. Yeah. That's right. I think before was like 3 seconds or something like that.
Yeah, it was more than 2 seconds.
More than 2. Yes. So. Okay. Great. Yeah.
Okay. Oh, do we have other questions? Maybe.
Yeah. Do
probably
we have
should-
more questions? We can. We're still here, so we can. Oh, they have questions too. Yes.
Is it also possible to run it outside of clusters? So, for example, on premises, is it beneficial? For example, we aim for
On-prem.
low latencies, and we have problems with Kafka for this. So, if it's suitable.
What do you mean? Can you? Is the question that is it possible?
What did you mean? Like it's cloud native. So if we can
Oh, yeah.
run it outside of cloud.
Yeah. It means that you can develop it
Yeah.
in the cloud.
That's right.
That's
Yeah.
probably a preferred way to do
That's
it. That's Kubernetes support, Helm charts. You have everything you need to deploy it to the cloud. Of course, if you want to deploy it on bare metal on your own server, it's
On-prem.
also possible.
Yeah. Yeah. It's
There are
supported.
multiple ways to deploy.
Yeah.
Of course, the traditional
On-prem.
on-premise
On-premise too.
is supported with Pulsar.
Yeah. That's
Can you compare the performance?
Oh, performance.
Latency-wise.
So latency between
performance.
on-premise or in the cloud?
Well, against Kafka, for example.
Oh, against Kafka?
Then, yeah.
Of course. We will have far better performance and
Yeah, that's
latency
right,
than
yeah.
Kafka.
There's actually a report from Stream Native that they did a benchmark
yeah,
too.
that-
we
that's
can
a-
share with you if you want to
That's
take a
a
look at that
great
report.
discussion.
Yeah.
If you ask us, we will say that it's better
Yeah, it's
performance. If
better.
you ask
Yeah.
Confluent, they will say they have better
That's right.
performance.
Yeah.
One of the key differences is that Pulsar does f-sync. It syncs every write on the disk by default. It means that even if you lose all your cluster, the full cluster all at once, then it still works, which is not the case with Kafka. They don't f-sync. So if you do f-sync if you compare Kafka default with Pulsar default, Kafka may be a little faster because it doesn't do f-sync on the disk. You can enable f-sync in Kafka and you can disable it in Pulsar. So then the results are interesting. My understanding is that you will get the same performance. At some point, the limitation is your
The
disk.
machine.
It's the speed of the
Your
disk.
machine.
And for latency, I would say that Pulsar has a more stable latency than Kafka. The reason is that in Kafka, you write to a leader and then it's replicated to the followers. And you need to wait to have enough followers to return an acknowledgement to the producer. In Pulsar, you write to multiple, the broker will write to multiple nodes of Bookkeeper at the same time, and as soon as it gets enough responses from Bookkeeper, it says, okay, I can acknowledge the write. So even if one of your nodes is slow, your storage node is slow, it's not a big deal because you will have other nodes that will be faster to answer to the request, to the write request.
right.
This is very technical, but since you
Yeah,
ask,
that's a good. Yeah. Okay. Oh, you have one more
Yeah,
question.
I have a question.
Sure.
So I've heard a lot of advantages today. I was just wondering some of the well-known issues with Pulsar.
well-known issues with
Well-known
Pulsar.
issues with Pulsar?
Uh,
I wouldn't say like really big issue, but it is true. It's a newer framework than say Kafka. The Kafka's the whole ecosystem is bigger, more people using. So yeah, in some ways, I think we're catching up, right? I'd say
Yeah.
we're growing. And
Yeah, I would
so-
say 1 year or two, Pulsar
Yeah.
was the problem was that there were no companies supporting it
Supporting it, yeah.
officially if you wanted to have enterprise support or in
That's
the
right.
cloud services. Now there are multiple
Yeah,
ones, including data stacks.
yeah.
And also, of course, Kafka has been there for forever,
Yeah.
and it has a huge ecosystem.
That's
But
right.
since now you can use the Kafka ecosystem on Pulsar, we believe
That's
that we are on
Yeah.
par on this.
That's right, yeah.
On this.
Yeah.
stand.
And just to mention too, if you're having Kafka, we actually, DataStax, we have open source library, Starlight too. We have Starlight library API for not just Kafka, but RabbitMQ and JMS. And these are natively protocol talking to each one of them. So you can also consider kind of, connecting, bridging Kafka to our Pulsar as well. So using Starlight, so yeah.
So does that
Yeah.
mean that Kafka streams will work with Pulsar?
Exactly,
Yes.
you can use
You
Kafka
can
streams
too.
with Pulsar.
Yeah.
We have customers using this in production.
That's right. Yeah. That's right. Yeah. Well, thank you. Yeah, I'm still here too, and I think Christophe too. So we can also always answer your questions while we are still here. Also, we have some stickers from DataStax and Kafka and Pulsar, not Kafka. So please feel free and take some stickers with you too.
Yeah.
So yeah.
We can mention,
Yeah.
so there were
That's
some
right.
resources for Spring
Resources,
Pulsar, other resources for
DataStax,
DataStax. If
Yeah.
you want to go,
That's right.
if you want to try Pulsar, you can have a Pulsar instance without a credit
Yeah,
card in
that's right.
minutes.
It's the
So
extra
it's really easy,
datastax.com.
nothing
Yeah,
to install.
that's right. Yeah, we're free tier. So yeah, that's right. And with that, yeah,
You publish this slide somewhere.
yes.
For example, if you write
A Twitter, if we tweet it out, right?
do the application for the event.
For the event. Oh yeah, that's right. On the WOFA, with the thing.
Ah,
Yeah.
yeah.
Okay,
We
we'll
can publish it.
do that. Yeah, we'll publish that.
It will
Thank
be-
you.
it
Thank
will
you
be
so much.
probably-
Thank you. Thank you. Thank you.